Welcome to this video. I'm Physics and today we are going to be going over resistivity. So first of all, what is resistivity? Resistivity is the measure of the resistive power of a specified material to the flow of an electric charge. The formula for it is R equals rho L over A, where R equals resistance, rho equals resistivity, L equals length of material, A equals cross-sectional area of the material. So now we are going to be going on to an example exam style question, where it states that a filament bulb contains a tungsten filament of diameter 3.8 times 10 to the power of minus 5 meters, and an uncoiled length of 1.6 meters. As the temperature of the filament increases, the resistance of the filament increases to a maximum, which is 14 times greater than the initial resistance at room temperature. Determine the power of the filament at maximum brightness. PD across filament equals 240 volts, and resistivity of tungsten at room temperature is 5.6 times 10 to the power minus 5.6 times 10 to the power minus 8 ohm meters. So we see that we need to find the power. So we know that power equals P equals IV, but we don't have I and we have no way of working out I. So instead of I, using V equals IR, we can make I the subject and rearrange V equals IR. So we're left with V over R equals I. And so we could substitute that with the I. And then so we're going to be with P equals V over R multiplied by V, as there's a V here as well. And so we're just going to be with P equals V squared over R. And so we also need the resistivity formula, which is R equals rho L over A. And so the resistance that we get from the resistivity formula will be substituted into this equation to find the power. And that's how we find the power. So first we need to find A, which is pi r squared. So we can see that the diameter is 3.8 times 10 to the power minus 5. So we can just half that to find R. So pi 1.9 times 10 to the power minus 5 squared equals 0.00000000113 meters squared. And that is the area, and we're given rho, which is over here, and we're given L, which is over here, 1.6. So we can just find R by substituting these values in. So when we do that, we will get R to equal 79 ohms. But we can see that the resistance of the filament increases to a maximum, which is 14 times greater than the initial resistance at room temperature. But we could see that the resistivity of tungsten at room temperature is that. So what we found was the resistance at room temperature as well. So we need to multiply this by 14. So we can find the new resistance. And so when you do that, you'll get 1106 ohms. And now we just need to sub it into the power formula, which is 240 squared over R, which is 1106. And when we do that, we will get 52.08 watts. And that is the answer. Don't forget the units, as it's not given in the question. So there we have it. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.